the policy tip, we wish to allow any user that sits on a specific LAN. It can be your marketing division LAN, it can be your finance LAN. Each LAN will probably have a different subnet to get out to the internet over the outgoing interface, which is our WAN interface. Our WAN interface is the interface that is connected to our ISP. Now, in terms of source, we will allow any source to get out to the internet. We can also limit it to specific users or different user group. We can create a user or a user group using the plus sign. We can also limit the traffic to a specific device. So if we, for example, want only Linux devices to get out to the internet, we can limit it to a Linux PC. Now, we will not do it. As for destination, we are not limiting. We will let anyone get out to any destination, but we can limit the destination towards a specific address. As for scheduling, we can limit our policy to work on a specific day, on a specific hour, but we will not do it. Anyone can get out to the internet always. And the last part of the first step in our policy procedure is this service. We can limit this service to be HTTP, HTTPS, or any other service, any other protocol that we wish to limit our users, but we will not do it. Users can use just about any protocol, any service. And then we decide on the action. Are we accepting the traffic? Are we denying it? Or maybe we are using it as a learn policy. A learn policy is a very specific policy that actually triggers security profiles beneath that no one really knows that it's there, and it learns our traffic and creates a report that we can look into and see users' traffic, most used applications, threats, and so on. The second part is the UTM profiles. We can initiate any UTM profile, any security profile on our policy. And the third part is whether we are enabling NAT. We have seen how NAT works using a NAT overload, IP pools, or maybe central NAT. And then we decide whether we want our policy to be logged with log all sessions or only security events. That's the basics of a simple full access policy. If you enabled Web Application Firewall on your Fortigate, then you need to know of XSS, cross-site scripting, one of the most known and malicious attacks on web servers. More on XSS coming right now. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. When you think of web apps, any web app, in its basic, it is built around three components. That's the very basic. There's HTML, the markup language. There's the programming language which adds interactivity into the page itself. We usually use JavaScript. And there's the CSS, which is responsible for the styling. Now, think of a web app that when a user enters an input into one of the forms fields or any place that a user input is needed, it doesn't sanitize between a pure data that is text, and a malicious code. Malicious attackers use XSS for different reasons. It can be a harmful reason, such as changing the look and feel of the web app, its background image, or color or type of font, but it can also be used to steal cookies from the user, to grab screenshots of its computer, or to even insert a keylogger that will send any keystroke to a specific URL. There are actually two types of XSS attacks. The first one is reflected XSS. That is XSS attack or malicious script that is reflected on the victim's browser. And the second one is stored XSS, which is the malicious code that is stored in the web app database and is executed every time when the user calls the specific function. Now, what can you do with XSS? Well, just about anything. If you head over to XSS payloads, you can find out different JavaScript payloads that can be inserted as a malicious code on a web app field or form and can be used to capture keystrokes, can be used to take screenshots out of your screen, or even grab images from your webcam. So XSS is pure evil when it is used in the hands of the wrong man. Let's look at how the JavaScript itself looks like. So that's the JavaScript itself. Now, in most of the cases, the JavaScript code also takes the information that it grabs. It can be a screenshot from your computer or even your cookies that are being stolen and sends it to the attacker URL where they can grab it and use it against you. One very known attack is when you use XSS to steal some other user's cookies and then you head over to the same website and pretend to be that user. Five best tips for using your antivirus within your Fortigate. The first one, choose whether to use it in a flow-based mode or a proxy-based mode. You can see that in a flow-based mode, the features are quite limited, but moving into a proxy-based mode, you can see that you have much more options when using antivirus. The second tip, choose your database. There are actually three main databases that you can use within your Fortigate. There's a fourth one, which is a compact database, but you can use the config antivirus settings and set the different database. You can use the default database, the extended database, and in specific Fortigate models, there's also the extreme database, which actually includes just about any signature. Our third tip is use grayware and heuristics. Now, when you scan using antivirus, the first step is to look for known signatures. The second step is to look for grayware. Grayware is not by definition a malware. It is an unsolicited program that usually downloads to your computer without you ever knowing about it. A good example is an adware. So how do you enable grayware? Again, config antivirus settings, set grayware. Now you can enable or disable. My tip, always make grayware enable. Alright, now for the fourth tip, use heuristics. Now what is heuristic? Heuristics, let's just, alright. Let's config antivirus, but this time not settings, but heuristics. Now, heuristics is actually an analysis of behavior, the way a file behaves. Now, Fortigate looks for different patterns, and if the file behaves in a suspicious way, you can determine what to do with it. Now, you can set mode to pass the suspicious file, you can block the suspicious file, or you can disable the heuristic features. Now, why do you need or why do you want to disable this feature? Because it adds up much more false positive events. So use it carefully. My fifth tip and the last tip is use hardware acceleration for antivirus scanning. Now, acceleration works only on the flow-based antivirus, not on the proxy one. And Fortigate models that features the NP4 or the NP6 can accelerate the antivirus processing to enhance performance. So use it by typing in your command line config IPS global, set npxl mode and choose none or basic. Basic actually enables the acceleration itself. And the last tip that I have for you guys is don't forget to subscribe to FortiTip. Let me show you the best application control tips for your Fortigate, and we start right now. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. Application control scans your traffic, your network traffic for applications that you wish to control. Now it does so using the IPS, the Intrusion Prevention System engine, and its protocol decoders. Now, the order of the operation is quite significant. The first thing it scans is the application override, that is different signatures. The second thing is filter override, where you can group applications that have the same behavior, such as excessive bandwidth. And the last thing it does is scans for the different categories. So if you wish to block a category such as gaming, and yet you wish to enable a specific game such as the Battlefield game, you can do it. And let's just select the signature. And Fortigate will start by scanning application override. It will see that the Battlefield game is, let's make it allow, let's make it a monitor, in monitor mode. It will allow the game, still it will monitor it, keep logs of it, and then it will look for the filter overrides. Currently we don't have anything in the filter overrides, and then it will look at the categories where it will block any other game. When the IPS engine finds a match to an application, it tells your Fortigate that it found an application ID number. Now, Fortinet keeps a database of some thousands of applications. Each one has its own ID. If you wish to see the different IDs for the different application, you use the CLI, config application list, edit 0, config entries, edit 0, and then set application and a question mark. And now you can scroll between the different applications and their ID. The next tip may seem obvious, but I have seen cases where users created application control sensor and believed that it is globally enabled on any firewall policy. Well, that's not the case. Whenever you create an application sensor, name it, and then use it in your different policies, and the application sensor will be available only through that policy alone. Whenever you as an administrator block an application, don't forget that your users deserve an explanation why that application was blocked. So for an HTTP-based application, you can use the replacement messages for HTTP-based application. Make sure that it is enabled. Now, when you enable it, your users will get a blog page that will include the following information. The signature that detected the application, the signatures category, either gaming or peer-to-peer, the URL that was specifically blocked, the client source, that's the IP address of the client, and the server's destination. Now, another thing that the block page includes is the FortiGate's hostname and the UUID of the policy that was governing the traffic. It is good in an organization that you have many FortiGate devices. You can look up at the hostname of the FortiGate and tell which FortiGate actually blocked the traffic. Now our last tip, which we will include a specific video on it in the coming future, is traffic shaping. You can actually traffic shape any application and allocate guaranteed bandwidth or maximum bandwidth to that specific application. It can be your Netflix or whichever application you use the most. Now you configure a traffic shaper and you configure a traffic shaping policy. That traffic shaping policy can be determined on a specific policy and specific categories such as video and audio, where you can actually select different applications such as the Netflix application. Fortigate Captive Portal in 3 minutes. Here's how. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. So you have outsourced employees connected to one of your interfaces and you wish to restrict the access to the network. What do? You use Captive Portal. How? Here's how. The first thing to do is to create a new user group, a user group that is dedicated to those outsourced employees. So let's create one. Let's use the guest as our user group, and let's use email as a method to deliver the password for that captive portal. The expiration of the account is 4 hours, but you can change it. That's the first step. The second thing to do is to create an administrator that is responsible only for the provisioning of the guest accounts. So let's use my name, let's use a password, and let's restrict that admin for guest accounts for the outsourced employees. Now, the third thing to do is to head over to that interfaces that our employees will connect through. And let's move over to the security mode. Let's choose, usually it is none. Now, we will use Captive Portal. We will restrict it to that outsourced employee group. And we finish the third step. Let's create a policy that will allow outsourced employees to get into the network, and outsource EMP. The incoming interface is the interface of the outsourced employees. The outgoing is our WAN. Source will be all and will be outsourced employee user group. Destination is all. Service is all. All right. Now let's log out and let's get into the new admin page that will allow us to create password for those employees. Now let's use my email, and Fortigate will generate a password that we can print it out or send it via email. Now if we log out again and enter with our super admin credentials, we will see that in our user group, we already have one member, which is the member that we have sent the password to that email. Hey everyone, this is the second part of how certificates work. We will unleash the mystery of certificate, and in this part we will look at asymmetric encryption. Well, asymmetric encryption works using a key pair, two different keys that are related mathematically. Now, one key, which is the private key, should be kept safe. That's the secret key. The second key is a public key. Anyone can use it, anyone can look at it. You can encrypt using the private key or using the public key. You cannot encrypt and decrypt using the same key. You have to use the second pair in order to encrypt or decrypt. Now, we will look at OpenSSL and how do we generate a key pair. One is a private key and the second one is the public key. But the beauty of asymmetric encryption or using a key pair is the fact that they're not only used in encryption, they are also used to authenticate the identity of the second peer. A server that wishes to have a digital certificate must generate a key pair. It must generate a public key and a private key. There are different algorithms that will allow it to do so. We will use RSA. Now we'll use OpenSSL, GenRSA, and let's name our key pair. Let's name it Fortigate, and let's contain it in a PM format, which is a container that will include both keys. And let's decide that the size of the keys will be 2048 bit. And that's about it. Now, if we wish to see both the public key and the private key, to inspect them individually, we can do so using the following command: OpenSSL RSA. Let's insert the file that we have just created, fortigate.pm, and let's get the public key out of it, and let's name it mykey.pub. Alright, it's writing it. Let's see how it looks. Let's open the key, and that's our public key. Now, if we wish to see the private key, we can use the following command: and that's the private key. So we have a public key and a private key, and those two are used when a server requests a certificate using a certificate signing request. It sends the public key as a part of its information. We will look later on how a certificate authority takes that information and actually creates a digital certificate plus a digital signature that will prove that he or it is the one that it claims to be. Hey everyone, back to Fortigate certificates, and in this part 3 we will look at hash functions. Now, what is a hash function? A hash function is a mathematical function that takes any input and produces a hash value. Now, the hash value is always in a fixed size according to the hash function that was used. The hash value is also called a digest, and it should be impossible to produce the same value for two different inputs. So the function is actually collision free. Now, a hash function must be quick. It has to produce the hash value very fast, and a slight change on the input should change the entire hash value completely. So even if we have a 1 gigabyte file full of text and we change a comma in one of the sentences, the hash value will change completely. So we have the input, we have the hash function, and we have the digest, the hash value. Now, when do we use it? We use it for integrity. Whenever we send a file, it can be just about any file, and we want to check its integrity, that no one touched it, no one tampered with the bit stream. We make a hash value out of the file, and then on the other side we compare the same file using the same hash function. If the two hash values are the same, then no one tampered with the file. If the hash value changes, then someone probably touched the file. There are dozens of hash functions that are used just about anywhere. When a web server stores passwords in its database, they are being hashed. They are being hashed using different hash functions such as the SHA-256 or the SHA-512. To make the hash stronger, we also use what is known as a salt. We generate random numbers to be added to the password itself, and thus the hash value will be much more difficult to guess. Now the term guessing is the right term, since hashes are in no way an encryption technique. They are not used for encryption. They are only a mathematical function, a one-way mathematical function that takes an input, turns it into another value, and there's no way back. They are not reversible. Alright, so enough with that. Let's move over to OpenSSL. Let's reproduce some hashes out of different inputs. And at the end, that will probably be part 4 of the series. We will recap what we have learned by now. That is symmetric encryption, asymmetric encryption, and hash functions. And we will look at certificate, a digital certificate, and understand how it all matches. Alright, so we'll use OpenSSL, but let's start out by using the echo command. And let's write down some text. I have a secret message. Alright, now let's grab it into OpenSSL. And let's use MD5. MD5 is a hash function that produces a 128-bit value. Now that's the hash value of that text. Now if I'll use the same text, but I'll change the E to an A, you'll see that I get another hash value, completely different hash value. Let's go back to the same text, and it will produce the same hash value as before. Now if we will use the SHA-256 hash function, you can see that we actually get the output as a 256-bit value. It is much stronger than MD5. We can also do it using the 512-bit, which produces stronger hash value. Now, how does it all have to do with digital certificate and digital signatures? We will look at it in our next video, which will be the last part of the series. But let's just look out at a digital certificate. And as you can see, we have the public key, which is the asymmetric encryption. We also have a signature algorithm, which is the hash function, as we just spoke about. And in part 4, we will see how it all mixes out with the symmetric encryption to make sure that we have confidentiality, authenticity, and integrity. One of the toughest topics to understand when we deal with security appliance is probably the world of certificates, digital certificates. Why? Because understanding certificates means that you have to understand what is asymmetric encryption, asymmetric encryption, and hash functions. Now, we will start with a video series that will try to lighten up the issue, and we will start with a basic introduction to symmetric encryption. We will do it using OpenSSL. So asymmetric encryption means, and that is the very basic meaning, that we take a plain text, we use an algorithm, which is a mathematical function that uses substitution and uses transpositioning, and we are using a key that is known to both parties. The key is the same. Later on, we will deal with the key space and what does it mean. And now we will take the plain text and we will use the algorithm together with the key to turn it into a cipher text. So if we'll open up a text file and let's write down Fortinet secret key, and now let's save it. Let's save the file as Fortinet. Let's open it again just to make sure that we have the plain text. And now let's use OpenSSL. Let's use AES 128. AES is a symmetric encryption algorithm. In our case, we are using a key space of 128 bits. That is 2 to the power of 128. And let's insert the Fortinet text and let's output as cipher text. Let's call it Cipher Fortinet. We are asked to insert a password. The password is not the key. The password is part of the key derivation. So let's enter the password. Let's enter it again. And now we have a ciphertext. Let's look at the ciphertext. We have called the ciphertext Cipher Fortinet. And there it is. That's the encrypted plain text. Alright, so here we are at the top 5 diagnostics command for your Fortigate, and we start with the first command, which may look a bit simple, which is the get system status. Now this command is very basic, but it gives you a lot of information. It gives you the virus and IPS database version. It gives you the serial number of your Fortigate. You can tell if you have a hard disk or are you using only a flash memory. It also tells you, are you participating in an HA cluster or not. It gives you information of the operation mode. Are you working in a NAT mode or maybe a transparent mode? Are you using another virtual domain or are you using only one virtual domain? So a lot of information in that simple command. This second command is the get hardware NIC and the interface name. In our case, let's look at our WAN interface. Sorry, it's WAN1. And that tells you of each interface its MAC address. Does it support any hardware acceleration? In our case, we support MP4 Lite. Do you have any dropped packets in your interface? Is the status up or down? Are you working in a full duplex or maybe half duplex? And what is the speed of your interface? In our case, it's 1 gig. Our third command is the get system performance status. Now, personally, I love that command since it tells you a lot of your Fortigate. Now, at the top output, you will see how many CPUs your Fortigate module supports. The following thing is the RAM usage. And at the bottom, the output shows your network traffic, the amount of average sessions per minute, and so on. So you have your CPU usage, you have your RAM usage, and your network usage. Next up is probably one of the most known when you deal with the Fortinet firewall, and that is the diagnose debug flow, which actually shows you the flow of your traffic from the CPU perspective. So you have to enable it. Let's enable